Hey students, in this video I'm gonna just summarize what the notes of 8.3 were about, which is technically just practicing the solving equation process with exponents and with radicals. So pretty much we explained that when you solve equations, we need to recall that we are solving using PEMDAS, going backwards instead of down, going up, and that's just guiding you on the order of how you should be solving. So as far as radicals land on the level of exponents. So please make sure you need to add or subtract or multiply or divide coefficients first before touching the radicals. Another thing we talked about was shortcuts of how to eliminate roots or fraction exponents or rational exponents. We talked about if you have the root, like if you have cube root, the way you will erase that or eliminate that is by cubing it or to the third power. If you have something to the third power, you can eliminate that by cube rooting it. So it just kind of cancel each other. Here we have the fractions, how they can cancel each other. So you have pretty much to raise it to the power of another exponent. That is the reciprocal. So if you have x to the 2/3, you want to cancel the 2/3 or eliminate it, I guess, by raising it to the power of 3/2. This is the flip version of 2/3, which is the reciprocal. And what's going to happen there is that you're going to end up multiplying exponent times exponent, since that is the power rule, power to a power. When you multiply a fraction, so 2/3 times 3/2, you end up with 6/6, which is 1. And that ends up being technically your new exponent, x to the 1 power, which results in just x. And this just proves how we can eliminate and keep the x, but eliminate the exponent of a fraction. One last thing was remembering also about square roots. There are times that we will have extraneous solutions when working with square roots. Whenever you do have a number that you plug in and check, and if you ever happen to have a negative number inside the square root, that cannot happen because it'll result in imaginary numbers as a solution. So we're not going over the topic of imaginary numbers anymore. We're just recalling that whenever you do have a negative number in here, you can't do the square root of it because the answer needs to have an I. But also vice versa, if you're doing the square root of a number and your answer over here is a negative number, keep in mind that that is possible. Here in this last part is saying that whenever you do square roots, you have a positive and negative version of the answer, since you end up multiplying two numbers times themselves, and they both could be positive times positive or negative times negative, and they both will result in that positive answer. That's what these little examples are for. All right, so let's go over these examples on the left side. I'm going to go over the 4 examples that we went over in class, and then I'll also do a couple more challenging questions in another video separately. All right, so the first example we have here is the cube root of x plus 6 equals 7. And in order for us to solve for x, we need to understand this x is inside the radical. So we can't touch it yet until we get rid of the radical. It is cubed, or actually third root, cube root. So we need to get rid of the root by raising it to the power of the root. So we're going to do whatever we do to one side of the equation, we're going to do to the other. Cubing the cube root cancels it, and we're left with x plus 6 equals 7 to the third power. So it's not 7 times 3, it's 7 times 7 times 7, which results in 343. From here, we are just simply going to solve for x by subtracting 6 from both sides. X equals 337. And that is done for that example. So from there, we build up on the next level, which will be adding or subtracting to it. And this is where emphasizing that PEMDAS works backwards, it's easier to see. We can notice as well the x has a number in front. which means that we cannot take off that number until we get rid of this exponent as a fraction, and we cannot touch that exponent as a fraction until we get rid of the 8. So it's several things happening, so that's why we gotta work backwards. So first we're gonna add or subtract, which means here we have to subtract 8 on both sides. Then we have 5x to the 1/4 equals -10. After that, we need to look at the exponent of 1/4 and remember that that technically means the 4th root of 5x. Some of you want to rewrite it and then cancel the root, or some of you will remember to multiply times the reciprocal. 1/4 flips into 4/1, which is pretty much a whole number of 4. So we can just raise it to the power of 4. The 1/4 times 4/1 cancels each other, and you're left with 5x. And then -10 to the 4th power is -10 times -10 times -10 times -10. So that is 10,000. And then the last step is to divide by 5. X equals 2,000. All right, so that is just pretty much the basic 2 levels of solving equations. Remember that you can always plug in your answers and double check if they are correct or not. Here we have the next level, which is also with the plus or minus, but in the front, we now have a number. So this is just like a coefficient, like if you had 4x equals 10, we want to divide by 4 to get rid of the 4. Same thing's going to happen here. So let's do the first step, which is to add 5. And you end up with 4 cube root of 24x squared equals 24. And then from there, that's the 4 that we're going to focus on getting out of the left side. So we're going to divide, because right now it's the coefficient of this radical. So by dividing by 4, we kind of eliminate that 4/4. And then I have cube root of 24x squared equals 6. To eliminate the cube root, and this goes back to like 11-1 equation, you just raise it to the power of 3. And then for this one, you're going to have equals 216. And then 24x squared on this side. To get the x by itself, we want to get rid of the 24. And that leaves you with x squared equals, I believe it's 9. (216 divided by 24). Yes, it's 9. And then this is where you look at x squared and you say, how can I get rid of x squared? Well, the opposite will be to doing the square root. So x equals plus or minus 3. And this just means that you're going to substitute a number in here for x, either +3 or -3, and it's going to still create the equal and balanced equation of one side equals 19. All right, and the last problem that I'm going to go over, here we have solving for n. This n is inside this radical, so we can't work with it until we get rid of the radical. So this radical is a square root. We're going to go ahead and square it to eliminate that square root, or undo, technically. We're going to have 110 minus n equals n squared. And then in this part, you need to notice that you have a quadratic equation happening here. So you need to factor in order to solve. So either the factors equal 0 or 0 equals the factors. In order for us to do the factors, we need to have all 3 on the same side, either on the left or the right. But keep in mind that you do want to work with positive n squares or x squares. So that means we need to move the 110 and the -9. We're going to subtract 110 and we're going to add n. And that's going to result in canceling these. and we're going to subtract 110 and add n to the right side. That will result in 0 equals n squared plus n minus 110. So this is a trinomial that could become two factors if we do the x. The x means we're going to use the strategy of a times c on the top and b on the bottom to find what these factors are. A times c is 1 times negative 10, so that's negative 110. B value is positive 1. So what two numbers do you multiply to get 110? That will be 10 and 11. To get positive 1, you subtract 10 from positive 11. These numbers will go in factors if your a value is 1, which we have confirmed. That is the a value following the ax plus bc equals bx equals c. So because a is a 1, we're just going to write those numbers in there. X minus 10 and x plus 11. We are almost done. We need to just solve. Solve for these factors. And solving process just means grab a factor, equal it to 0, and solve. Grab a factor, equal it to 0, and solve. So right here, x minus 10 equals 0, so we can just move the 10 to the other side, or we can imagine that a number needs to go there to equal 0. So the opposite of this number, 10, positive 10 minus 10 is 0. So here, x equals 10. That's one answer. And then on this one, x will equal negative 11, since negative 11 plus 11 equals 0. And that concludes this video, or at least the examples that we did for this video. If you have any questions, come to class and I'll help you.